Hi, hello, and welcome everyone. So today we're here to talk about your application modernization journey. What we're doing is Top is going to give you an introduction from a Microsoft perspective to explain how Microsoft comes to the fore to help you modernize your applications. And then what I'll be doing is breaking that down into further detail, explaining all the components in Microsoft Azure that you can use to look to modernize your applications as you choose to really truly digitize and move your organizations forward. So over to you, Top.
Yep. Thank you very much, Piers. Hi everyone. I think some of you may already met me in the meeting or some meeting, right? So again, my name is Top. I'm a cloud solution architect from Microsoft for the app modernizations. So from this page, right, you will see that application modernization. Normally, when you think about application modernization or why the customer want to do the app modernization, normally they think about the faster time to the market, especially on the developer teams, right? They want to be fast to go to the market. So they want to think about the increase of the security and reliability and innovation on top of that. And most of all, it's about the cost reductions that happen, right? With the Microsoft Cloud Platform, right, we offer the unique and differentiate position to help you drive the innovation here. So for example, achieve the faster time to the market using the low-code solution like Power Platform, Integration Platform, and Logic Apps, for example. Using the Arc Control and Azure DevOps to help you manage the consistency, the governance on the code and the environment, right? And the manage security and high availability on the PaaS service that we have. Example, the SLA of 99.995% on that database. And innovation, normally we talk about the AI and ML, right? Which Piers will walk us through more details later on. And yeah, on top of that, on the cost benefit itself, we provide you with the more than 50% right, discount on the Azure Hybrid benefit and also the Azure Dev Test subscriptions. So if we move on to the next page after this one, we will see that, okay, this is the entire architecture platform that we provide, right? We provide everything from the virtual machine up to the container and the PaaS service. And then we talk about the low code implementations, right? We are the only vendor here that can support you the entire modernization application development here. So we use virtual machine for the most of the control and flexibilities. We use the PaaS platform and serverless and low cost for productivity, right? And the managed environment on top of that. So if your goal to the modernization is to reduce the cost, or you want to integrate the data AI in the future to your application for rapid deployment and things like that, then Microsoft is one of the platform. So let me hand over to Piers so he can show us more in details or the service, how it connected together. Over to you, Piers.
Thank you very much, Top. So after the introduction, hopefully you understand that the Microsoft Technology Stack provides you a host of features that can help you look to modernize your application. So I want to chat a little bit about what that modernization journey looks like and the technology involved. So before I do that, one thing I always like to talk to my customers about is when you think about modernizing an application, and certainly looking to modernize an application into Microsoft Azure, we have to think about making sure that we've set up Azure and we've made Azure ready for the applications that we want to put in. So in most organizations, it's not just about one application, it's about an entire estate of applications and infrastructure that you start to modernize as part of a towards cloud journey. And application modernization is really just one part of that. So I don't want to leave you here feeling that, well, we can just go modernize the application without thinking about a little bit more than that. But Microsoft does provide guidance in this respect. So we have a thing called the Microsoft Cloud Adoption Framework. I provided the link there for you, and it will be sent after the call as well. And really the purpose of the Cloud Adoption Framework is to help organizations like yourselves with partners like us or on their own to actually get to the point where they start to adopt that cloud technology properly. So the first part of that framework is content that helps you understand how to define a strategy and get your strategy set up, planning, which allows you to analyze your environment, come up with the right business cases and the order of execution. Ready. So ready talks about making sure, and the most important part over here is get that landing zone, the green one I've highlighted, up into Azure, ready to start to set your applications and infrastructure. Technical skilling, making sure your resources have the right skill, and then into adoption. And the important part over there that I always tell customers is when you think about modernizing your estate, your application estate, as you start to move into Azure potentially, this happens in waves. You don't pull a pin and move all your applications in one go. You typically modernize and you migrate in waves. So that process about plan, ready, and adopt goes through a set of waves. underpinned by a set of governance and management technologies that allow you to manage a platform as well as to govern what's happening on that environment. So it's important to understand that application modernization and individual application modernization would typically be one wave in your full adoption framework. You can read more about the end-to-end adoption framework, but I really just wanted to introduce you to that concept in case you're not aware that there is guidance from Microsoft about how to adopt the cloud, of which modernization of apps is one of those key assets. So when you think about application modernization, we have to understand why we want to modernize applications in the first place. Now, generally what we find is there's a set of triggers or a combination of triggers that drive customers to look to modernize. And these modernization triggers include things like data center contracts expiring. So very often we find our customers sitting inside of traditional data centers. They have a desire to move to the cloud. And really their pulling point is the fact that their contract's going to expire. They don't want to sign for another 3 years. So they have a pressing date in order to do that modernization or migration. Quickly integrated acquisitions. So this is this idea that your organization procures or acquires another organization or is merging into another organization. And often what we find is leveraging cloud technology to help us modernize the applications, to really breach some of that integration becomes an important thing. Urgent capacity needs. And this is one of the ones that I come across the most. Organizations hit a growth spurt and they find that the traditional on-premise infrastructure is not able to scale to the capacity as and when they need. They wait weeks to get another SQL server up and running, whereas they want to be able to grow their capacity quite quickly. So that's a good reason to consider modernization. Software and hardware refresh cycles. So hardware in traditional on-premise infrastructure has come out of date. We're looking at a refresh cycle. Software, the same purpose over there. Security threats. So often what happens is legacy applications aren't necessarily that well protected. So the idea here being is if we can land this up in the cloud and we can start to turn on and enable some of the additional Microsoft security and compliance controls, we can start to protect our applications. Compliance, obviously in and of itself, the idea that says we want to make sure our applications are compliant with some of the most stringent standards because we may be performing in one of those sectors where we have those standards. Application innovation. So application innovation is probably one of the biggest drivers, if not the biggest. So we have a legacy application we want to modernize. We want to modernize that application. We can't modify the code's legacy. We can't change it. So what we want to do over here is break that application apart, put it back together and start to include some modern technology like cloud services for machine learning and AI. These types of technologies that allow us to take advantage of new opportunities in our markets. And lastly, one of the most common ones as well is obviously end of software support. So I'm running on a legacy version of .NET framework or a Java framework. I'm running on a legacy technology stack. I'm running on an old version of a database platform that's now end of life support. I need to look to migrate and upgrade that anyway as part of my application stack. And what we find is typically customers have an array of these drivers around a specific application that prompt that need to modernize, often led by the innovation need. So why do customers in summation choose to modernize? Well, really, first thing is it allows us to consolidate and optimize our cost because it means that what we have the opportunity to do is to redesign or rethink about our applications so we end up in a situation of paying for what we're using. So we can scale up and scale down as we need to. We can have the opportunity to really scale down our non-production environments and only scale those environments up again when we physically need them to be operational. We have the opportunity to mitigate risk. So risk with regards to obviously the technology from a security perspective, we can have things like advanced threat protection turned on. And most importantly, very often as we choose to modernize our applications, and I'll talk about the continuum of modernization just now, we want to get away from necessarily having to patch the underlying operating systems and technologies that our applications run on. So we want our applications really to be this thing that says we as developers and builders and managers of these applications are worried about the functionality of the application, and we want Microsoft to take care of that underlying patching and management of everything underneath the hood to take us away from that, and obviously making sure the risks are managed. And obviously the innovation piece that I mentioned earlier, that's a key driver in terms of the choice of migration. So now that we understand hopefully the position of why customers choose to migrate, let's talk a little bit about the way you look at your modernizing your application. So we talk about the 4 R's over here, and the 4 R's are effectively rehost, refactor, re-architect, and rebuild. So what does it mean? When I take a look at my application, I have an option. The first option I have is to rehost. Really what rehost is lift and shift. take that application off on-premise physical infrastructure or on-premise virtual infrastructure and move that application as is up into the cloud running on virtual machines natively in Azure IaaS. The idea here is it should be the quickest opportunity to move. There is no change and we can deploy the code as is. So what this means is if we think about cost of project and time to migrate, quickest to migrate, quickest project cost, lowest CapEx cost, potentially doesn't give us the best OpEx approach because essentially we're going for the most expensive option when we use this option to get into the cloud. But it does allow us to get there quickly and allows us to start to mitigate some of that operational concern that we may have. For example, existing data center contracts expiring, the ability to scale up, have additional scale on that underlying platform quite quickly if we needed to. So rehost is definitely a valid option for legacy applications. The next option is, well, what if we have the opportunity to refactor? So if we start to think about an application in layers, which I'll show just now, we have the opportunity to refactor one or more of those layers to take advantage of some more native services in the cloud. So a good example is we might decide instead of running everything on a VM, we decide that we're going to take the application front end and run it in an app service. Or we decide that we're going to take the application database and instead of running it on a SQL, an Oracle, traditional physical deployment, we choose to deploy it in a platform as a service technology stack. And what that means is it means that we're starting to refactor, we're starting to use those cloud services more ubiquitously. This doesn't necessarily give us innovation in the application, but what it does is allows us to control the operational cost of that application and to scale a lot more effectively. So we've really started on that modernization journey. And as you can see, as we go up the graph over there in the slide, that means that we start to make better use of cloud services. If we then think about re-architect, so re-architect really talks to this idea that says what we want to do is we want to materially rethink about how our applications put together. So we're going to still use a lot of the code that we already have today. We're not completely rebuilding and rewriting that, but we're going to look at how we can take and break apart what potentially may be a monolithic solution and take that application code and modularize that code. So we materially decompose that. And what we want to do is run those modules independently so we can scale those modules independently and really start to take advantage of some of that cloud native architecture as we start to build out those solutions. There is a fair amount of code rewrite, but definitely we're using the majority of the code that we already have. We then go to rebuild. Rebuild is really the most expensive option and takes the longest to do. But sometimes when you look at the application, the cost benefit analysis of rehosting, re-architecting that application, it says actually it's better to rebuild. Now, this doesn't mean you don't use assets you already have. Yes, you will typically use some code that you already have. You often use existing database architecture and up that up and move that up. But what you're thinking of doing is really starting to build your application ground up completely natively using some of the tech stack that you have. And what we find is most customers today sit somewhere between refactor and re-architect as their sort of end state of their application modernization. Then what they typically have is an application lifecycle and it says by some critical business events, some digital transformation, some of the desire to enter a new market, they may choose to completely rebuild some components in future in the application space. So typically this is a continuum. It is also a bit of a roadmap. And most of our customers, as I said, end up between refactor and re-architect on their existing applications as we go through. So that's the continuum that we live in when you think about application modernization. So when we think about that continuum, I like to talk about applications in terms of the layers and the layers of modernization that one needs to think about, that all applications possess that we need to think about managing in some fashion. So if you look at the layers of an application and the layers that we can attack modernization there's really a couple of components. So first, there's a user experience. So this is the way that end users interact with your application or solution. How do they interact with it? How do they work with it? How do they engage that solution? You know, are they on a mobile app? Is it a web application? Is it a thick client Windows Forms type application? How do they actually interact with that application? We then have the application logic, and really this is the logic that has all the business rules and all the functionality inside of that. Often what we find, legacy applications is that the user experience and application logic are quite tightly coupled together. It doesn't necessarily mean that you have to break them apart as part of your migration journey, but it is something worth considering. So we have our user experience, our application logic, which is all that rules and the logic and the process flow and everything that makes our application do what it's supposed to do. And then we have data storage. So our applications typically capture data and they report in data, and we want to be able to work with that data. That's really the data storage layer. So this is where typically our databases and our file stores that live inside of the data storage layer. Things that people often forget when they look at this, they often look at applications and they think about just these three areas, but there are two other really important areas that our applications have. So we have security and identity. So very often when we look at modernizing legacy applications and we start to lift it into the cloud, one of the things we start to think about is, well, how do I manage who can use this application? How do I manage the role-based access into this application? What technology stack am I using to make sure I'm giving myself the best chance of making sure the credentials are protected and people are logging in and I've got a security layer around that application that makes sense? Whether they be internal customers, i.e. your users, or whether it be your customers, suppliers, and partners, you need to think about a way to manage that security. And the last one over here is integration. So integration is a big one. Most applications today have a tie into something else. It's very rare we come across a situation where there's a line of business system that does everything on its own and it doesn't talk to anything else. So when you think about modernizing your application stack, you also need to think about how does this application stack, as I look to refactor and re-architect, how does this application stack talk to the things that it already spoke to? How does data come into it and how does data go out of this application? Where does this application live in terms of the integration technology stack? And the good thing is Microsoft has answers for how we can approach each of these areas. One of the things that people often raise when I show them this picture is, well, Piers, what about microservices? So even today, if you have a microservices architecture or you move into a service-oriented architecture of some sort, typically what you'll find is those services you build live within the application logic and data storage layer. So they too themselves individually have logic and they have data storage that we need to think about modernizing as we work through the technology stack. So essentially the premise holds true. So I'm going to start off with some detail then about the application modernization piece. And really that's a bit in the middle where very often the vast majority of the work that you have to do when you look at modernizing the application actually occurs. I can't talk about that application layer without talking about cloud native, because I think there's a lot of misconception about what cloud native is. So it's probably good just to clear that up, because one of the things we want to think about doing when we refactor and re-architect is potentially move towards a cloud native architecture because of the benefits it gives us. So cloud native, as we say, is a new paradigm of software development. And really the analysts say that by 2022, 35% of applications or production applications will be living in this cloud native stat. Now this stat is quite old, it's from 2018, but it's still holding true. And certainly what we're seeing in the market today, this is definitely the case. So when you think about cloud native, we have to ask ourselves what it is. So the cloud native computing foundation has a very nice long definition that's quite confusing if you read it in its entirety, as I've put it on the board over here. So I thought I'd just summarize that for you. And really, what does cloud native mean? Really, it boils down to these things. It means that we need to be able to run scalable applications. These applications are dynamic and they can be living in public or hybrid clouds. That's what they need to be able to do. Very important, the infrastructure, i.e. the thing that these applications run on, must be coded. We don't manually be deploying infrastructure. We should be able to run code to automatically spin up the infrastructure that these applications run on. They're resilient, which means they can recover from failure. If one node fails, another node should take over with no issues experienced on the end user application lifecycle. These things are manageable. So we need to be able to manage them both from a development environment, but also as we're into production, we need to really understand and be able to easily manage these things. Observable, understand what's happening, and robust automation. Probably one of the big pieces about cloud native is we need to embody a set of automation in how we deploy, manage, and deliver our application. Cloud native is not prescriptive about using Kubernetes or serverless. I often hear people say, I have to use Kubernetes if I want to be cloud native, or I have to use serverless. So cloud native says we can use these tools to assist us to embody those capabilities, but it's not prescriptive about that specific technology stack that you may use. So what is cloud native essentially then? Really what it means is it's a way for us to package application code and dependencies into a set of containers or serverless functions and deploy those things as this microservice architecture, and more importantly, using DevOps tools to drive it. So what does it mean? Typically cloud native says we want to start to consider using containers to host our application code, and really what that means, it abstracts the code from the underlying infrastructure differences. So I can deploy a container into an app service or into an Azure Kubernetes cluster, and my code should just run automatically there. DevOps. So DevOps is about enabling the DevOps process, not just for the CI/CD and the automation of deployment, but also the collaborative process to actually modernizing and building those applications as we go. Microservices, really this talks about taking our application where everything may be bundled together and breaking that application down into a set of very loosely coupled microservices that don't have any direct dependency on each other. They talk to each other through some sort of messaging infrastructure. And what this means is I should be able to modify and change some of these microservices, which are typically responsible for a specific domain, like there might be a microservice for order processing, and all it ever does is order processing. I should be able to modify order processing without affecting the sales module. And they should be kind of disconnected from that perspective. We then have the opportunities for APIs. APIs are really important when you start to think about being cloud native, because what it is a prescriptive way about how we expose our application or our application logic in that application tier to the rest of our architecture, whether it be for integration or whether it be for user interface perspective. It provides a standard way to expose that. And most importantly, what APIs are going to do for us is when you start to use API management for your APIs, it means that we start to take away some of the non-functional development requirements from our developers so they can focus on core logic. So that is what cloud native is. Microsoft supports cloud native. If we think then about what it's really going to do for us at the end of the day, it means that cloud native promises we should be able to innovate faster, our applications should be more reliable, and we can apply security at scale. Now that we hopefully have a basic appreciation of what cloud native is, it's important to understand your applications and where your applications are going to go. So when we look at applications that you typically have today in your environment, you might have web applications that are monolithic architecture. And what that really means is it's all kind of bundled together in one, all the logic, all the front end, everything lives in one place. And typically there are a couple of places we can move those type of applications to without having to go through a re-architect and a rebuild phase. So that would be essentially what we do is either go to Windows virtual machines, but really the recommended approach for these guys is to move in Azure App Services, which I'll talk about just now. We then have N-tier applications. So this is where our applications are built up of multiple core services, so not fine-grained. It's typically you have a very well-defined front end, which is the user interface. You have a very well-defined middle tier, which is the set of services, and you have a very well-defined data tier. And if you have this, it means that you have a good opportunity, obviously to VMs, that's the lift and shift option, but certainly to move into Azure App Services. It's a great fit into Azure App Services. If you have a very large application portfolio, then it's definitely worthwhile considering moving into Azure Kubernetes services as really the cheapest way or the most cost-effective way we can run that for that really large portfolio. So it's a good option to consider over there. We then have cloud native. And this is really if you already have a microservices architecture or as part of your modernization journey, you're going to go down that re-architect solution where we look to break up our application into new architecture. And then we certainly start to look at using Azure Kubernetes services and Azure Functions, which has really given us some of that event-driven programming paradigm where one microservice does something and it raises an event. So I have received an order and an event may be received on the order being received. And then what might happen is the customer domain might receive that event and go send an email out to the customer to say, by the way, your order's been processed. So that's why we start to look at that technology stack. So when you think about applications by solution type, really cloud native starts to play in a role when we go down these areas over here. And really what it boils down to, part of being cloud native is to go down that kind of re-architect or rebuild phase. But we certainly have really good options just to move your applications in their interim state into Azure App Services, which many of our customers choose to do because we get those immediate benefits from doing that first step of the process. So that was summarizing the application logic piece of our component. So let's talk in a little bit more detail in that application logic, what each of these technologies can do for us. First is Azure App Services, as I said, one of the most common ones. So what is it? It's Microsoft's fully managed app service. It's really like a web server that you traditionally have on-premise today, except without all of that management overhead of running the actual web server itself, but very similar paradigm. It's certainly this, why do we do it? It's the simplest footprint to get up and running, and most application code will just run in that. It's very easy to scale out as well, because what we typically do there is define an app service plan, and we then go and deploy multiple web applications or APIs into that app service plan, and that app service plan is supported by underlying compute nodes. And we can tell the app service plan as and when it's supposed to scale, which means the application can fairly easily automatically scale in that regard for us. So really good technology stack. When would I typically recommend using this? Legacy monolithic applications, as I said, or traditional NT architectures. This is a good fit. Why is it good? When I really want low management overhead. So there's very little I have to do to keep this up and running, monitoring and management. If I want some very basic scale modding. So I've explained it does scale. It's quite basic in the way it does it, but for very many applications today, it's a great fit. It has very wide support for .NET, Java, Node, Python, PHP, and others. It supports containers as well. So as I said, if you do even choose to containerize your applications, we don't have to go down the full Kubernetes, Azure Kubernetes route. Certainly we can have the Docker containers running inside of our app service plans on Linux or Windows underneath the hood. Importantly, we have a component in Microsoft Lane called the App Service Migration Assessment Tool, and we can run this application directly on our application code and endpoints, and it'll let us know, essentially, is this application easily migratable, or is there any little things that I need to consider doing as part of that app service migration? So really, it's probably the easiest route to modernize that first step in your application journey, move it to the cloud, reduce the underlying maintenance cost of that application, take a whole bunch of that management overhead, and obviously getting the operational cost of actually hosting it down. And that's certainly something app services provide us with. Azure Kubernetes Service is really the next level up. So what happens with Azure Kubernetes Services is this is when we're starting to go down very often a microservices architecture, or we just have legacy applications that support native containerization. So this is Microsoft's fully managed container orchestrator. And really what it does is provides us the full cluster management of our Kubernetes cluster, which means that we provision this thing, we set it up and we configure it, and Microsoft takes care of actually managing that for us, unlike running Kubernetes natively on VMs or on-premise. Provides us all that management infrastructure for us. So we're only really responsible for running our container runtime and the containers in that runtime. Microsoft takes care of everything in the control plane tier. So when do we usually use this? Microservices or legacy applications. So very often this is when we're going down a microservices approach. We choose to use AKS as the landing zone for that microservices. But then obviously we have the opportunity, even in some legacy applications, we can package those applications up and drop them here. Like I said, if you have a very wide N-tier architecture, so many N-tiered applications following a similar pattern, this is a great user to migrate that whole stack into Azure. And we've done this for a number of our customers who have 10, 15 N-tier applications, and they want the best way to get those into Azure. In that case, going down the Kubernetes route or Azure Kubernetes route is a great answer. Cheapest cost to run, most control over what's happening inside of the environment. So very fine-grained control of scaling and network routing. And like I said, the lowest compute cost overall if you choose to go down this route. So Azure Kubernetes is a great way to modernize that application tier. Azure Functions, so we can't talk about application modernization on that app tier without talking about functions. So what are functions? These are completely serverless functional code. We call them for nano services. This is very useful if you have any event-driven types things happening in your application. An application needs to trigger an alert. Something needs to happen when something happens in your application. I save an order, I need to send out an email, or I save an order, I then need to raise an integration event in some downstream system. That's where Azure Functions plays a great role. So it's very fast, low code, and it scales down to 0. So what that means is that when it's not being used, we're not really paying for it. And that's a great opportunity on Azure Functions. Very good, as I said, for event-driven applications or low footprint applications. We use this very often when we look at modernizing integration processes, because it may very often what you find in integration, there's some really complex code that someone wrote once upon a time to transform message A to message B, really hard to go and rewrite the code. So we look at making it really packageable, package it up and put it in a function so we can raise an event to run that bit of code quite nicely for us. So there's good options for using Azure Functions there. API Manager, probably one of the most important pieces of glue when you look to modernize that application layer. So if I have an application and I've decided to split my user interface from the actual application logic, what we often want to be doing is wrapping an API manager around that application logic. Really what it does for us, it hosts those API endpoints, so it makes them discoverable and usable. It's policy driven, so the rules that apply are policy driven, so we can do things like have throttling, make sure that this API or this endpoint isn't hit more than this many number of times in this period of time. So we can manage the scale and the scope that it's dealing with. It can do things like automatically do logging for us. It can also do things like very often we use it to implement the security layer. So you don't have to rebuild the security layer in our applications. We can actually essentially transform that security layer and have API Manager implement the non-functional security for us. So really the idea is to remove the non-functional requirements for developer scopes, but very valuable in terms of our application architecture. When would I use this? Any modern service-based solution, we typically want to do this. Even if it's internal facing, we really want to have a good long think about using API Manager to host any of those endpoints that we're going to create. And certainly if our application logic is going to be consumed as logic by external partners, often for integration, then we look at using API Manager for that. So these are really 4 key components that I've spoken about over here in that application tier, which is App Services, the easiest one, the most common one to lift your application, move it into Azure, start to take advantage of some PaaS service. Kubernetes, this is when you're dealing with a large-scale end-tier architecture, or we've already started to go down a microservices route. Great option. Azure Functions for that event-driven programming paradigm. And then obviously, as I've said, API Manager really being the thing that allows us to wrap that business logic up inside of a set of APIs that we can do all that non-functional stuff in. Often I get asked, what about low code though? So great, Piers. I'm glad that you've modernized the application stack. What about this low code paradigm? So where we think does Lowcode really play a role in our modernizing of existing application? This plays a role very much in that user experience layer. So user experience being the interface that the user interacts, but also some of the human workflow type activities that happen inside of that UI layer. So how do we do that? We have the opportunity in Microsoft land to actually combine the best of both worlds. So in Microsoft, we have the Power Platform, and 2 key components in the Power Platform provide a lot of that user experience. So firstly, we can choose to rebuild some of our user experience, not necessarily all of it, but definitely some of our user experience we can choose to rebuild in the Power App. So Power App provides us a modern user interface. It's a really quick way for us to build a web-based type interface and have a mobile-based interface. So we can really essentially very quickly mobilize our application by building up the interface in Power Apps. Power Automate, this is really good for process orchestration as well as a human workflow orchestration, approvals and the like to drive that workflow logic inside of Power Automate. So really we have the opportunity to modernize our application logic and then choose to rebuild some of the user experience in the Power Platform. What is Azure do in this case? So that's where our application logic is sitting. So what that means is our core application logic, the data and the process stuff lives in some of those APIs that we're either hosting in Kubernetes or we're hosting in App Services behind API Manager. And API Manager, in fact, is the glue here. One of the great things that Microsoft has done is they made it really easy for us as application modernizers to take that application API and make it available into Power Platform. And API-M is the way that we do that. It's really easy to do. So once we've defined an API inside of API Manager, we choose export and we choose to publish it into a specific Power Apps environment. As soon as I've done that, then developers or front-end developers in the Power App platform have the opportunity to connect directly to that API and use it inside of their applications. So we have the opportunity to quickly modernize some of that code and API Manager providing that connectivity. Now, this capability is available in obviously Power Platform Plan 1, etc. But even on the freemium tier inside of Power Platform in Teams, you can connect to this directly and build those applications for yourself on top of those. So really good opportunity for combining those 2. What does it look like in the back end if you chose to do this modernization? Well, you'd have Power Platform obviously in the front end for browser and mobile app. It engages through API management platform, and depending on how your APIs are exposed, it would go through Azure Functions or an Azure App Service or an AKS container environment. And obviously at the back end of that, we'll be talking to one of the modernized data layers typically. So you can modernize your application stack and really quickly go build a new UI on top of it using that Power Platform or that low-code development. So certainly an option to consider. So that's the application layer that we've covered off. So in summary over there, we spoke about the idea of what cloud native really means. We've covered off how Microsoft supports cloud native. We've spoken about the different options for modernization depending on the type of application. And we wrapped it up talking about opportunities to think about modernizing that user experience with some of the low-code tools provided by Microsoft. There's more in application modernization. We also obviously have to think about the data storage layer. So what about data modernization? So in the Microsoft world, we have the opportunity to take obviously databases as they are, those database platforms, and lift and shift them into virtual machines. That's what the bottom icon is trying to show. But we also have the opportunity to migrate off some of these other technology stacks and move them directly into an equivalent Microsoft Azure platform as a service for databases. So we, for example, can take Azure SQL Server or Oracle, and we can migrate that technology stack into Azure SQL. If we're running MySQL or PostgreSQL as the backend of our application, we have opportunities to migrate those directly into the platform as a service, Azure MySQL or PostgreSQL. For any of our document DB type scales, we would typically migrate something like MongoDB, if you're using that, into Azure Cosmos. The great thing that Azure Cosmos provides us with is we can make that migration and still support the MongoDB APIs, which means I don't actually have to change any of my application logic when I migrate one of these document DBs into Azure Cosmos type document database. So that's a great modernization approach that we have over there. How do we typically look at doing this? Well, Microsoft provides tooling to support this. Firstly, there's assessment tooling that allows us to analyze these different environments, come up with a set of recommendations, and allow us to know if we can directly migrate that. We then have direct migration service tooling that allows us to lift those databases and dynamically convert them into the relevant equivalent in the PaaS services with very low hands-on involvement in that process. So in the early days, this was quite difficult to do. It's really improved now, and I encourage you to work with some of those assessment tools to look at migrating that data estate for you. The thing about the data estate is the data estate isn't just the data estate. Often when we start to talk about the data estate, we have to have a think about, does our application have any BI capability in it? So what would we typically do from a BI or a decision-making support capability? Well, looking at the Microsoft traditional stack over here, if, for example, you're running an ETL process, so in Microsoft land, we would call that SSIS typically. Often what we do is we'd lift that any of those ETL processes, we move into a product called Azure Data Factory. And Azure Data Factory, in this case, is really providing us that ability to perform that batch-based data movement, that data transformation capability. The great thing about it is, for those who already have SSIS, it supports rehosting of those SSIS packages or rebuilding your data, your ETL processes in the native pipelines. So if you are running ETL, we have the opportunity to do that. SQL Server reporting services, or if you're running something like Crystal Reports, so any paginated report type solution, the way we would look at redoing that in the Microsoft land is we typically use Power BI Premium or Power BI, great for dashboard type solutions, Power BI Premium providing us that paginated report experience, just similar to what you would typically get out of SSRS. So we can still deliver paginated reports as the migration path over there. And then if you're running any of your analysis services type use cases that you might be running, so your cubes, etc. on-prem, we can migrate that directly into Azure Analysis Services. But very often what we find these days today, many of the typical analysis services use cases are fully supported natively in Azure Power BI Premium. You don't necessarily have to spin up the same models inside of analysis services in your use case. So that's a bit of a have a look at your use case and make the decision. I think the important part about the data estate is we can migrate the data layer to equivalent PaaS platforms. We don't have to go to VMs, although that could be a first step. And obviously we can migrate the BI layer that we might have on top of that data layer into equivalent tool sets that we might have in our technology stack. The next thing we're going to talk about is integration modernization. So when we think about applications, like I said, many people focus on user experience, logic, and data, and they forget about the fact that the applications talk to other bits in the environment. So integration certainly is an important part of that. So when you think about applications do exchange data with each other, and that means we have to think about it. So if we choose to refactor, re-architect, or rewrite our application, in other words, we're not just going for a traditional lift and shift approach, we can actually break down or decompose the application and rewrite certain components, then it's certainly worthwhile in sync with that, looking at redoing or rethinking about the approach to integration you use for that application. And what we recommend is consider implementation of some of the native Azure tools, particularly the Azure Integration Platform as a Service features, which I'll take you through now. When we look at rehosting an application that's just taken and putting in a VM, what we really need to make sure of there is, because we're not going to rebuild the integration there, we need to make sure that we have connectivity set up so that application can still talk to whatever the old endpoints were. So this is where we start to enable at the networking tier things like hybrid connections, so our app services or applications can still talk to the existing on-premise endpoint or other cloud endpoints it needs to. So rehost is important to really think about the connectivity from integration. But if we're going to be doing a little bit more, so we're going into the re-architect or refactor type stage, then we start to look at thinking about adopting some of the PaaS tools for integration. I always draw this picture to scare people a little bit, just to show what your application may be doing. And very often when we unpack an application, we find out that it does have a whole bunch of these integration layers, particularly those big line of business applications. So your application may very well, for example, be integrating with on-premise internal systems, and it may be doing that either through batch database migrations, or it may be going through some kind of a queuing mechanism where it drops messages in a queue that are picked up, or the on-prem system drops messages in a queue and your application picks up the processes. Often your applications interact with external places. So maybe your partners, your customers, and your suppliers may have the desire to interact with the application. Again, you may have events that raise directly to them. You may also be sending files back and forth and integrating those into your application. Often what we also find in the application modernization arena is that some customers have gone quite advanced with this and avoided this sort of point-to-point thing. Often what they do is they have some kind of an orchestration layer over here that is responsible for dealing with that integration with multiple systems. And this is where we may want some kind of a bus technology architecture to allow us to more at an enterprise level complete that integration. The good answer is for all of these scenarios that you may have in your application stack, Microsoft does provide capability in that regard. So this is really the integration need and the iPaaS feature. I'm not going to discuss each of these individually at this level. I'll go into some detail now. But really, when you think about integration, our applications often have a need from a pattern perspective to extract, transform, and load, to take batch files and put them in. Sometimes our applications have a need to multi-system complex orchestration. So our application gets a message, it has to send a message somewhere else, wait for a response, and then send it somewhere else. So we sometimes have that. Very often, in certain industries, you have specific protocol connectivity requirements. So for example, in healthcare, we have HL7. So we have a need to support that particular standard and pass messages of that format, and in terms of that process, have that wrapped up. We have publish and subscriber models. We have message queuing. We have the need to do business to business. We have event driven. We have low latency. We have monitoring and measuring. These are things that you need to think about when your application integrates with the outside world. You may have some of these patterns. The good thing is, again, that Microsoft has technology that allows us to bolt on or build these integrations in a modern platform as a service way into our environment. So I'll chat about some of those quickly. So the first one that we have is logic apps. I use logic apps when I want to do this in a low-code way. So what I want to do is I want to drag pictures and I want to draw what that integration or that orchestrated integration looks like. We typically use this for near real-time or message-based scenarios where we basically want, when something happens in the application, we want to pick it up and we want to orchestrate that integration across maybe 3 systems and we want to get a response back. So like a scatter-gather pattern, for example. It's really good for that. When do we use this? Those event-driven applications, low footprint. This is a good option to look at considering using logic apps. So logic apps, great for orchestrated integration, low-code build environment for yourselves. Functions, this is typically where we want to run code, and very often we find that there's an overlap between logic apps and functions, because often we might have a very specific bit of code to do a very complex transform, and what we want to do is instead of writing the whole integration as code, we'll just write that transform logic as code, and often what we'll do is from our logic app, which is governing the integration, we'll call the function which will do the complicated bit of code and return a result so we can move on with the rest of that integration process. So really great for that. Some customers choose to build all their integration in functions, which is completely doable if you're going down a code first approach, because functions also provide the ability to do orchestration through an idea of durable functions. So we have that ability to do that. So why do we use this? Low latency, and if we have some really complex codified code, we would want to put that inside of a function and call it from our solutions. The next option we have over here is a technology stack called Service Bus. So queues are just a fact of life. Whenever your applications need to integrate with something else, there's often queues in between. And the reasons queues exist is because what we want to do is decouple the application that's sending the message from the application that's receiving the message, so these two things can operate independently. We need a queue system in the middle that will promote, retry, and guarantee delivery of some of these messages. And that's what Service Bus is aiming to provide us with. That queue in the middle that protects these applications from direct point-to-point integration. So it provides us message queues, which is a message comes in, and a message goes out to its target. It provides topics. A message comes in, and multiple subscribers in a pub-sub model will receive that same message. So really useful. Why do we use this? Pub-sub implementation, non-repudiation, which you guarantee to get the message over there, and most of the standard integration patterns that you will already have in your applications will need a queuing technology stack. So great user for that. When do we use this? The basic way is when your senders cannot wait for the receivers and transactions are considered asynchronous. That's when you look at using service bus as the thing that lives in the middle, the queue. This is also excellent if you're looking to migrate parts of your application estate into the cloud and leave other parts of the application estate on-prem. Often we find that we choose to have a service bus in the middle, making sure that we control the flow of messages between these two environments. So that's integration. So key parts. So what we've covered so far is the application logic, probably the biggest piece, and we've understood there the data storage migrating to PaaS. We've covered integration because it is something to consider if your applications are doing integration. How do we modernize that? And we've spoken about components that can help. The last bit over here is what I call identity and security. So as we move to the cloud, if we look at refactoring or re-architecting, one of the things we need to think about is how do I identify myself as a user into this application estate? What technology am I using? So very often what we come across when we look at these modernizing of applications is often customers haven't implemented an SSO paradigm today. Often these applications are using some kind of basic or forms-based authentication. And as part of moving these applications to the cloud and modernizing them, it's a great opportunity to think about refactoring that. And the way that we look at refactoring that typically in the Microsoft land as we do this modernization is we look to remodel how end users authenticate. And the technology platform we choose to use that is Azure Active Directory for all of our internal user. So why? This is an enterprise-based, cloud-based identity and access management or IAM solution. Why do we do it? Because it gives us SSO. So that means the identities that a user are logging onto Office and to Teams, etc. It's the same identity that they're accessing the application. Out of the box, it gives us the ability to turn on multi-factor authentication, so immediately protecting our applications more than we're using basic forms-based authentication. And most importantly, Active Directory allows us to create application identities, which is a key facet of how the components of your application, as you start to look at refactoring them into maybe a more service-based thing, how those services know to trust each other. Those applications have identities, and that's how they have access resources in your environment. So really a key element. So definitely something you want to consider doing. When do we use it? Any of your internal users, as well as your application identities. What about external users? So often applications that we have in our environments today involve interaction with customers, suppliers, and partners, and they have some kind of a login to get into that application. And very often what we find in traditional legacy applications, that has been implemented as some kind of a forms-based authentication where username and password is typically saved in an encrypted state, hopefully inside of a localized database. What that means is the level of protection that's provided is really quite low, and we don't get the opportunity for more advanced capability. So what we have in Azure is a thing called Azure B2C, which is built on the backbone of what Active Directory has, which means we start to have a whole bunch of the same features and policies that Active Directory has. So the first thing it provides us with from a technology perspective is it allows us to have those consumers and citizens authenticate. What it does is it allows us to use local identities or federated identities. And federated identities are important because that means with very low amount of code, I can automatically provide OAuth authentication against those social identities. So immediately I can start to take advantage of people using Facebook, Twitter, LinkedIn, and other logins based on those OAuth and OpenID Connect standards and turn those on in my application without having to hand code a whole bunch of that technology. So it's really easy to rethink about the way you manage those external identities. The local identities, this is when you choose in your application not to use those channels and you choose to have a B2C manage those identities. And the great thing is the user interface and all the technology behind it works exactly the same way that AAD does. So as you choose to migrate your internal to AAD, your external to B2C, the usage of those things works in pretty much exactly the same way. The UI for this, for providing login, is all pre-built. You can choose one of the default ones, but it's also policy-driven. So you can change that login and auth flow and the process and the sign-up flow. And you can also completely customize the user interface in the process, all backed by the security that Microsoft provides that need. So it's really a great component to consider. It even enables you to, at a premium level, turn on MFA. So you can even force MFA on your external custom identities without, as developers, having to build that from the ground up as we look to modernize some of that security layer. When do we use this? External access with or without social federated identity. Typically, we use this when you see that there's forms of authentication. We need to replace that. Many of the applications MOQ is modernized and help customers modernize. When we take those applications, this is one of the first things we look at, and it's a really common process to do this migration, to move on to B2C and to move on to AD, just to reduce the overhead of managing the security layer and letting Microsoft deal with that from a best practice perspective. One other key element, and there's lots more to security, I'm just focusing on pure application stuff over here. One other key element over here is how do I protect the endpoints of my application? And the way that we typically look to do that is we want to put some level of firewall and OS top 10 protection and WAF on top of that. In Azure, we have two options. We have a component called Azure Front Door, and we have a component called Application Gateway with WAF. Really what the difference is Azure Front Door is the global entry point on the Microsoft backbone, which means it's really at a global scale, whereas Application Gateway is a regional gateway that you typically set up in your Azure tenant that protects your application where it is. And really those are the two options. AFD I find is really quick to set up and get running and connect to your application. So for many of our PaaS applications, we choose to go the Azure Front Door way, but Application Gateway is also another option. Typically, if you're having, based on your security posture, to bind all your applications directly into virtual networks inside of Azure, the way to expose those typically would be through Application Gateway with WAF turned on. Why do we need all this stuff? Well, we need it because we want to protect the application endpoints that may be exposed to the internet, right? We want to be able to turn on the policies and have the OS top 10 implemented. Also, what happens is Azure Security Center hits into this, so you can see any threat and analytics happening on that and understand if someone's trying to get into your application, and obviously understanding this potential vulnerabilities you need to think about closing. So really, this is a very important part, and I see too many people modernize the applications and completely forget about protecting the endpoint and just leaving it hanging out there on the internet. So Microsoft provides you out of the box with App Services, for example, with the denial of service protection, but you still need to protect the actual application endpoint. So these are two high recommendations as you think about that modernization. Last thing, DevOps. We can't talk about modernizing application across all those different tiers without thinking about how do we make sure that the code gets built and deployed. So we have two options in Microsoft land for that, and it's certainly a good idea when you think about modernizing applications. If you aren't already using these tools, is to think about how do I lift my existing old school source control management and the complete manual build processes. How do I take that and lift that up? So we move that into one of two options. Either you move it into GitHub with GitHub Actions, or we move it into Azure DevOps. And really the difference between these two components, firstly, Azure DevOps is a little bit more mature. It's been in the market longer, so there's some more features from an Azure support perspective, but GitHub Actions, slightly newer, has most of the same capability. We've used both in customers very successfully based on direction and preference. The good thing is, what do you use it for? Any of those automatic build and release, the idea being click a button or publish a branch and then have that solution automatically deployed into test. Once it's approved, automatically deployed into production. So hands off that full deployment process and run those tests automatically as part of that. They both use the same syntax. They both have the concept of steps or stages. The big difference, Azure DevOps has an additional capability for work item management and test management. So test backlogs and work item management. Many customers may be using Jira, in which case often they might say, I'll use Jira for my backlog management or one of those tools, and GitHub will take care of my CI/CD process. So you have those options. The most important thing about actually doing this is don't just look at migrating the code and automating that. Also, you want to migrate or automate the infrastructure. So everything we do in Azure, we want to automate, deploy, and have up and running. And we have the ability to do that with both GitHub Actions and DevOps, and we deploy that infrastructure as code using ARM templates or Terraform and something like that. Really important to do that. So a quick summary of what we've heard. I've got 5 minutes. So the summary of what we've heard hopefully is you can create a foundations approach. So before you hit the application modernization, make sure that you think about the cloud adoption framework and have some basics in place so that you're landing your modernized application into something that forms part of a roadmap. Select which areas of your applications you're going to rehost, refactor, and re-architect. And to be clear, you don't necessarily do all in one. It's a choice based on the application. Choose a data layer and application host layer that makes sense. Think about remodeling integration and identity. Take advantage of the modern cloud services. So one of the great things about being in the cloud, you have access to all of those additional services that Microsoft provides. And consider if Lowcode is going to add value to improve your turnaround time on building out some of those specific user experiences. So where to next? MOQ, we're offering a free one-day modernization workshop where myself and some of my colleagues will come and sit down with you, look at one of your applications, help you work out what the options and the approach to modernization. We'll document a high-level approach to you, and that's led by our digital and foundational consultants. If that workshop outputs something that's useful and makes sense, we have the opportunity to work with our colleagues at Microsoft to see if there's an opportunity for a co-funded engagement where maybe Microsoft and MOQ may put some money up to help you actually start that migration journey. We have an ebook that we'll send out afterwards that you can read that summarizes much of what I've just said. So that's it. And I've got a couple of minutes for questions. Sorry, I ran a little bit longer than I thought.
We did have one question, Piers.
Yes.
And it was, how would you describe the learning curve of application developer / infrastructure teams moving from a prem to app services rather than rehost to LAS? LAAS.
Okay.
Yeah.
Cool. Okay. So it's a great question. So I think when you're going from on-prem into app services and you're not essentially rebuilding your application, it's just a rehost, the learning curve is quite low. And specifically, that's why that's often the first step for people, because you're not talking there specifically about changing the application code. We're just talking about getting it deploying into Azure. And the learning curve, when I say is quite low, is, I mean, for developers, it's pretty familiar to stuff that they know. For infrastructure folks, there's obviously a bit of a learning curve because there's new technology in the way that we talk about provisioning resources in Azure. Probably one of the biggest learning curves that we come across is getting the infrastructure folks up to the thing and understanding that they can actually design the infrastructure as code. It's not to say doing it manually is bad, and often people start that way, but we want to help those infrastructure folks actually specify as code or declaratively what that infrastructure looks like so we can deploy that through the automation pipelines. But that first step into app services, it's why many people choose that, because you're not breaking your application apart there typically. There's very little from a developer perspective that actually changes. It's just more about learning there's a new host server as opposed to IIS or Apache that I'm hosting my application code in. I don't know if there's any other questions.
There is one other question, potentially maybe better to discuss offline.
About the funded engagement?
Yes.
Yeah, so I think, Top, I know if you want to take that one, we can answer it. It's a fair question.
Yeah, I think from this engagement, right? Is it funded or not on an engagement, right? You can see that where to next here, right? The first thing is maybe you do the MOQdigital, the offering free one day first. If you have the project in the pipeline that you would like to maybe change or modernize some application that you have from the on-prem to the cloud, then our account manager from the Microsoft will work with the MOQ, and then we will write down the scope of work and things like that, and then we can do think about the funded engagement after that. So
I think in summary, the funding isn't guaranteed. In short, is what you want to say. But once we've got an application scope in place, we can put it in front of Microsoft and make a business case to acquire some funds to assist in that process. But what we will definitely do for the customers is provide them that one-day workshop to at least understand what that scope of that modernization piece may be, so you have the opportunity to move forward.